Greetings from a cold and frosty Bolton, and good morning. And we are going to be looking at maths. Now, this week in maths we've got a few different things we're looking at. Over the next day or two we are looking at factors and prime numbers and square numbers and multiples. So we're going to be focusing on that today and then continuing on that tomorrow, looking at some different types of problems. Then also this week we are going to be looking at some of the stuff that I knew about 30 seconds ago when I started this video, but now I've forgotten. Justifying answers is one of them. Balancing equations is one of them. And looking at problems with lots of different operations within it. However, let's focus one step at a time, shall we? So we're going to go into my screen so that I can talk you through prime numbers, factors, multiples, and square numbers. Here we go. Welcome to my screen. Now, like I said, we're looking at factors, multiples, prime numbers, and square numbers. So, as we get into that, little thing for you to think about while you're watching this video, can you match up which one of these definitions goes with which of the things we're looking at? So, we've got square numbers, prime numbers, factors, and multiples. So, a number that has no factors apart from itself and 1, which one do you think that goes with? A number that is the result of multiplying a number by another whole number, which one do you think that goes with? The result of multiplying a whole number by itself, what do you think that goes with? And a number that can be divided exactly from another number, which one do you think that goes with? Now, we'll pop back to that in a minute, hopefully. So, let's first look at multiples. Now, I'm going to start off, I love a bit of counters, so I'm going to start off with some counters and then I will go with that. Okay, so let's say that we have 3. Hopefully you'll all agree with me that we have got 3 things there. Now, what multiples means is it's the result of multiplying that 3 by another whole number. So the multiples are things where if we get another 3, we put it together. So a multiple of 3 is 6. Okay, another multiple of 3, these are all the multiples. Another multiple of 3 would be 9. Another multiple of 3 would be 12. Another multiple of 3 would be 15, and we could keep on going and going and going. And as long as there's multiples, as long as we could split them into 3s, as long as it is the result of 3 times something, that is a multiple of 3. I mean, that also would be, that would be a multiple of 3. Because it is 3 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 30 there. 30 is a multiple of 3. So anything really in the 3 times table, so 9, 12, 15, 18, and it keeps on going, 330, 669, because I know that's in the 3 times table. That is what multiples are. So when we go back to this one, the multiple is a number that is the result of multiplying a number by another whole number. The reason I said whole number, because if I did something like 3 times 0.5, that would give me 1.5, which is not a multiple of 3. Okay, this has got to be a whole number. Multiples, hopefully we're okay with them. So now let's look at factors. Well, if I actually let's say take those for a minute. So factors. Here I've got the number 4, 8, 12, 16, 20. I've got the number 20. Now if I'm trying to find factors of 20, what that means is they are numbers that I can divide 20 by and still get a whole answer. So we would look and we would go, well, how can I split this up? What can I divide this by? Well, I could divide it into 4s. Yeah? So a factor of 20 is 4. And then they would all be in 4s. I could divide it by 5s. Okay, so I've got a row of 5, row of 5, row of 5, row of 5. So a factor of 20 is 5. I could divide it by 2s. Okay, if I could divide 20 by 2, I would end up with, hopefully you'd work out, 10 groups, and it's 2. Now factors usually come in pairs because 4 times 5 is equal to 20. 10 times 2 is equal to 20. And we will keep on going until we found all of the number pairs that go together to equal 20. So let's just do one that isn't with 20 and doesn't involve those. So if I was trying to find the factors of, let's say, 36. Okay, so the best way to start is with 1. So 1 and 36 can be multiplied together to give 36. So they are both factors. Then, can I multiply 2 by something? Well, if it's an even number, then I can. And it's 2 times by, hopefully you're working that out, so half of that is 18. So they are both factors of 36. Then I would say, is 3 a factor? Well, 3 goes into 30, so 33, 36. Yeah, it does. So 3 is a factor. And what goes with 3 is 3 times something to get to 36. And that is 12. Then, does 4 go into it? Does 4 go into 36? Hopefully you realise it does. And it's 4 times what equals 36? Well, it is 9. Does 5 go into 36? No, because that just goes into 35 and 40. Does 6 go into 36? It does, and it is 6. And to get 36, we do 6 times 6. Now at this point, that tells you something else about this number that we'll get to in a minute. But now I've got to 6 and I go to 7. 7 isn't in there. 8 isn't in there. And now I'm back to 9. And because I've got to 9, and 9's already on this side, that tells me that I've found all of the factors of 36. Okay, so going back to our first one, which one of these is the factors definition? A number that has no factors apart from itself and 1? No. The result of multiplying a whole number by itself? No. A number that can be divided exactly from another number? And that is what a factor is. Okay, moving on to square numbers. Now, hopefully you might appreciate this, but square numbers are numbers that, when you get counters like this, you can make a square. That's why it's called a square number, amazingly. So that makes a square because it is 2 lots of 2. 2 times 2. So 4 is a square number. A square number comes when it is the result of multiplying a number by itself. So the next square number would be 3 lots of 3. Hopefully you'll agree with me that 3 lots of 3 is 6 a square number. It's not, because you can't make a square with those 6, but you can make a square with 9, and that's why we call it a square number. Okay, it's the result of 3 times 3, which is 9. So the next square number would be the result of 4 times 4, which would be 16. Then it would be 5 times 5, which would be 25. Then it would be 6 times 6, which is 36. Then it would be 7 times 7, which is 49. 8 times 8, 64. And obviously that just continues going and going and going and going. But a square number is a number that you get from multiplying a number by itself. So going back to this one. A square number, a number that has no factors, no. The result of multiplying a whole number by itself. And that is a square number. So that leaves us finally with prime numbers. As always, you can pause this and watch little bits again if you need to. So prime numbers. And based on what's left, we know that a prime number is a number that has no factors apart from itself and 1. So let's say that I took the number 7, okay? Now if I got 7 counters, 1, 2, 3, 4, 5, 6, and 7. Now with these 7 counters, it is never ever going to make a rectangle, okay? Apart from if you had 7 in a row. So the factors of 7, I can divide 7 by 7 and it will give me 1. And I can divide it by 1 and it will give me 7. They are the only factors. There is nothing else that I can do. If I put them in 3s, I'd end up with 1 left over. If I put them in 4s, I wouldn't be able to put them in 4s. If I put them in 5s, I'd still have 2 left over. And so any number that you can't divide by anything other than itself and 1 is a factor. So if I took a number like 30, hang on, let's make a bit of space. If I took a number like 31, okay, and we need to decide, is that prime? Now, if those of us who know our multiplication facts really well, will probably straight away go, 31's a prime number, I'm pretty sure, because I don't remember it being in any times tables. So what you can do is to work out if something's prime, you can go, right, well, 1 and 31 go together. And if there's anything else that I can find that go together to multiply to make 31, then it's not prime. So 2s doesn't go because it's not an even number. 3s doesn't go because it will be 30, 33. 4s doesn't go because that gets to 28, 32. 5s doesn't go because it doesn't end in 0 or 5. 6s doesn't go because it ends in 6 and 0. 7s doesn't go because that goes 28 to 35. 8s doesn't go because that goes from 24 to 32. 9s doesn't go because that goes 27, 36. 10s doesn't go because that's 10, 20, 30, 40. 11s don't go because that goes to 33. 12s, 12, 24, 36 don't go. 13s go up to 26 and then 39. And then if you get into this amount and you've still not found one that goes, the chances of finding one are pretty much 0. Okay? So I'm happy that 31 is a prime number. So in quick summary, multiples are when you times a number by something else and it gives other numbers. Okay, so multiples of 3 of all of these. There are loads of them, infinite amount of them. Factors, they are the numbers that you can divide another number by. So on this one of 20, we found that you can divide it in 4s, you can divide, and that pair is 5. You can divide it in 20 and 1. You can divide it by 2 and 10. You could divide it by 4 and 5. I can't have said that. And then we looked at 36, and you can divide that by 1 and 36, or 2 and 18, or 3 and 12, or 4 and 9. Square numbers are the result of multiplying a number by itself. So if I said, what is the square of 10? You would say it's 10 times 10, which is 100. So 100 is a square number. And then prime numbers can only be divided by themselves and 1. So the questions that you're going to be getting today look a little bit like this. So you're going to have to draw these in your book. You might want to get like a cup or something and like stick it in your book and draw around it, or find something slightly circular to help you draw them. So if we get a question like this and it says, put the following numbers in the correct places. So this is a Venn diagram. So anything that's a multiple of 4 needs to go in this one. Anything that's a multiple of 6 needs to go in this one. And anything that is both of those needs to go in there. Anything that isn't a multiple of 4 or isn't a multiple of 6 needs to go in my square, but written out here somewhere. So let's do one at a time. And this is the way to do it. Always do just one at a time. So let's take the number 6. So is 6 a multiple of 4? If I count in 4s, does it get me to 6? Well, 4, 8. No. So it's not a multiple of 4. Is 6 a multiple of 6? Well, it is, because 6 times 1 is 6. So 6 goes in here. That one's done. Press it out. Next, 4. Is it a multiple of 4? Well, yeah, it's the first one. So I'm going to go, oh, hang on, wait. Is it a multiple of 6? No, because the multiples of 6 start at 6. So 4 is going to go in here. Okay, next one. 10. 10 sounds like a nice number. It's probably both. No, it's not. Because multiples of 4 are 4, 8, 12, which isn't 10. Multiples of 6 are 6, 12, 18, so it misses 10. So the 10 is going to go in our box, but outside the circles. 18. Is it a multiple of 4? Well, it's got an 8 in it, so it must be, mustn't it? No. No. 4, 8, 12, 16, 20. It's not in the 4 times tables. I can't multiply it by a whole number and get 18. Is it a multiple of 6? 6, 12, 18. It is, so it's going to go in here. 22. Is it a multiple of 4? It's got a 2 in it, sounds like it should be, but it's not. 4, 8, 12, 16, 20, 24, misses out 22. Is it a multiple of 6? 6, 12, 18, 24, it misses out 22. So 22 is going to go out here somewhere. 4 we've already done, so I'm just going to ignore that, that's my mistake. And then 12, is it a multiple of 4? 4, 8, 12, it is. Is it a multiple of 6? 6, 12, it is. So 12 is going to go in here. So I should have done 1, 2, 3, 4, 5, missing that one out. 6 numbers, 1, 2, 3, 4, 5, 6. I'm happy that that's right. Let's look at another one quickly. Well, this one and this one to do, and then I'm stopping the video. So put the following numbers in the correct places. Multiple of 3, so, or factor of 24. So 6, is it a multiple of 3? Well, 3, 6, it is. A factor of 24 means, can I divide 24 by 6 and get an answer? And the answer is 6, 12, 18, 24. I can. 24 divided by 4 is 6. So that is going to go in the middle. Okay, is 4 a multiple of 3? 3, 6. No, it's not. Is it a factor of 24? Can I divide 24 by 4? And I can. So 4 is going to go in here. 10. I'm going to cross these out as I go to them. Is it a multiple of 3? 3, 6, 9, 12. No. Can I divide 24 by 10 and get a whole number? No. So 10 is going to go on the outside. 16. Is it a multiple of 3? 3, 6, 12, 15, 18. No, it's not. Can I divide 24 by 16? Can I count up in 16s and get 24? No, I cannot. So it's going out here. 22. Is it a multiple of 3? 3, 6, 9, 12, 15, 18, 21, 24. No. Can I do 24 divided by 22? No. Next one, 4. Can I count up in 3s and get to 4? No. Can I do it? Oh, I've done it again. We've already done that. And then finally 12. Is it a multiple of 3? 3, 6, 9, 12. Yes, it is. Can I divide 24 by 12? Yes, I can. So 12 is going to go in the middle. Okay, those are kind of like ready and a bit of steady questions. And you might get questions a bit like this that look on go. 3 vens, we don't need to panic. Okay, don't go, oh, I can't do it, because you probably can. Anything that's in these 2 is going to go there. Anything that's these 2 is going to go there. And anything that's here means that it must be all 3 of them. So just do one at a time. So 6, is it a multiple of 3? Yes, 3, 6. Is it a factor of 24? Can I do 24 divided by 6? Yes. Is it a prime number? So is 6, can I only divide 6 by 6 and 1? And the answer is no, because I can divide it by 3. So it's going to go in this one here. Next one. 4. I'm always going to start off with the prime numbers actually. Well, 4 is an even number, so that means that it's not prime, apart from 2, because I can divide it by 2. Is it a multiple of 3? No. Is it a factor of 24? Yes, because I can do 24 divided by 4, so 4 is going to go in here. Next one, 10. Is it prime? No, because I can divide it by 5 as well as 10 and 1, and by 2. Is it a multiple of 3? No. Is it a factor of 24? No, so it's going outside my box. 16, is it a prime number? No, because I can divide it by 2 and 8 and 4. Is it a factor of 24? No, because I can't do 24 divided by 16. Can I count up in 3s and get to 16? No, so 16 is going out here. Next one, 22. Is it a multiple of 3? No, it's not. Is it a factor of 24? No, it's not. Is it a prime number? No, it's not, because I can divide 22 by 11 or 2. So 22 is going out here. Next one. 3. Is 3 a multiple of 3? Yes, it is, because I can go 3. It's the first one. Is it a factor of 24? Can I divide 24 by 3? Yes, I can. Is it a prime number? Can I divide it by anything else other than 3 and 1? And this one, the answer is I can't divide it by anything else, so it is a prime number. So 3 is going to go in here. Then 12 is a multiple of 3. It is a factor of 24. It's not a prime number, so 12 is going to go in here. And then finally 17. Is it a multiple of 3? No. Is it a factor of 24? No. Is it a prime number? Can I divide it by anything else other than 1 and 17? Well, I can't do 2s, I can't do 3s, I can't do 4s, I can't do 5s, can't do 6s, can't do 7s, can't do 8s, and then I'm past pretty much halfway, so no, 17 is a prime number. So, I need to start talking because I've been going on for a while. This has been a bit of a longer video, so make sure that anything you're not sure about, go back and do a bit at a time. If that last one completely confused you, that's probably only for Go questions. So if you're not planning on doing Go, then don't worry about that last one. Okay, you might just go back and read the first or the second, watch the first 10-15 minutes or something. Anyway, give it a good go, year 6, and tomorrow we'll be looking at this again. Okay, goodbye, and I will see you in the next magnificent, marvellous, mediocre maths lesson.